All right, in this problem we're going to look at using QC, the reaction quotient, to decide whether reaction is at equilibrium. If it's not at equilibrium, then whether it's going to shift toward reactants or shift toward products to get to equilibrium. So I'll rewrite our reaction here. SO2, 2SO2 plus O2 gives us 2 SO3s. Now the concentrations that we have here, been careful to write this, and the following concentrations are currently present. So have we waited long enough for it to reach equilibrium? Maybe, maybe not. These are just the concentrations at whatever time this was sampled. So, but nice for us, the form is the same. So, and different books use a different different things to represent this. I put a T here to just say that it's at some time T. It's not the initial concentration. It's not necessarily the equilibrium concentration. It's just the concentration at some time. And so same sort of arrangement though, products over reactants. And then we need to put those into the equation. So my concentration of SO3 is 10 molar. My concentration of SO2 is 0.10 molar squared. Both of those need to be squared. And my concentration of O2 is 0.1 molar also. So I'll put this into my calculator. And I get 1.0 times 10 to the fifth. So a really nice mnemonic that works in these situations is to write out a number line. And so on the left-hand side here is 0, and then it gets bigger. It goes in the direction of infinity as we go from left to right. And then I write my Kc. My Kc here is given 4.3 times 10 to the sixth. And then I need to decide where to put QC with respect to Kc. So QC, this is 1 times 10 to the fifth. This is 4.3 times 10 to the sixth. So my QC should go over here. And the nice thing about this mnemonic then is it tells me which way the reaction will shift. The reaction will shift from the left to the right. So it will favor products in order to reach equilibrium. It will shift, the equilibrium, the concentrations will shift from left to right. We will use up reactants and we will form products. And so let's see which one, the QC is smaller than the KC. So QC is smaller than KC. So it's one of these two. It's either C or D. And we said the reaction will shift from left to right. So C would be the correct answer here. If you ever get confused about these coefficients, like 10 to the 6th versus 10 to the 5th, you always can do this. 1 times 10 to the 5th, enter that into your calculator, go up here and go over to floating, and that gives me that top one is 100,000. And then 4.3 times 10 to the 6th. And then this floating notation, that is 4.3 million, 4,300,300. And with regular decimal numbers rather than scientific notation, it should be easier for you to sort out that 4 million is larger than 100,000.